13 students, thank you. We're going to talk a little bit today about probability in section 4.1. Now, I'm going to note that chapter 4, probability, really is the most complicated topic that we address all semester long. So come along with me. I'm going to share my screen and we'll go ahead and get going. All right. So section 4.1, some very basic concepts. We're going to work through some examples. Now, before we get to those examples, we're also going to do a little bit of review. We're going to go ahead and review the various methods we have to calculate probabilities. That'll also entail reviewing some very basic definitions. And then we're going to work through some very basic examples. Truly, it is not the math that is the challenge here. It is the topic, the context, the language. So let's go ahead and get going. Definitions. Now, an event, that's any collection of outcomes from some given procedure. You can flip a coin, have a baby, do something a number of times, record those outcomes, take a look at those things that happen. Those are your events. Now, a simple event is an event that really cannot be further decomposed into something even more simple. Events are basically simple or compound. Simple events, there's really only one way to describe them. Compound events, there might be a number of different ways to meet the description there. So I will note that we work with the sample space of a procedure, and that really consists of all possible simple events from any given procedure you might have. If you're looking at birds, it might be gender. If you're looking at coin flips, it might be head or tails. If you're rolling dice, it might be a 1, a 2, a 3, a 4, a 5, or a 6. So let's talk about how we calculate probabilities. At this stage, there's really only two ways of going about it. They both involve counting of some sort. I like to introduce the relative frequency approximation or method first. Basically, what we will do is we'll conduct or repeat a procedure any number of times. We'll take a look at a particularly well-defined event A and count up the number of times that particular event A occurs. The probability that A occurs in the given number of procedures that we do is a simple fraction. The number of times A occurs appears in the numerator. We divide that by the total number of times the procedure is repeated. So here we go. Here's a work example. So a study of US high school students found that 165 of them had broadband internet access from home, while 46 did not have that broadband internet access. Turns out to be kind of important in this virus day and age. So we're going to select one student from that group that was surveyed and asked about their internet connection speeds. We're going to try and find the probability that that particular person selected from that group has internet access at home. Now, to find that probability, we need to do a couple of things. We're going to need some clear notation. We're going to need some total values. We're going to need an expression that's given to us up above in our definition. And then we're going to have to round that particular outcome. So I'll let B, the letter B, stand for broadband internet access. So that's the event of selecting someone who has broadband internet access from home. How many people did we talk to? Well, 165 had access, 46 did not. 211 people were asked altogether. Now, the probability of selecting from that group of 211 people someone who does have that access, we make a fraction, 165 divided by 211. On our calculator, it's very straightforward. 165 divided by 211, hit enter, 0.7819905,213, and I'm sure there's more decimal places after that. So we don't want to write everything down. We want 3 significant digits. So let me go ahead and just remind people this is the number we want to round to 3 significant digits. So I go to the first non-zero number, that's the 7, and I count for 3 digits. 1, 2, 3. Now, I need to go one more and take a look at this guy here, the 9. The 9 informs me about what I must do as far as rounding the number 1. Because the 9 is 5 or larger, the number 1 will be rounded up to the number 2. So, .782. The probability of selecting an individual from that group of 211 is a 0.782. There we go. There's an example now of the relative frequency approximation method. It's not the only method we have. We also have the classical approach to probability. For our work here this semester, those outcomes have to be equally likely, whatever those outcomes might be. We'll see that in just a moment. Now, to calculate the probability of a particular event A, we count up the number of ways or times A can occur. And if it occurs S different ways, we're going to remember that. Now, if the procedure has n different simple events, we make a basic fraction. The probability of event A is the number of times A occurs divided by the sample size space, literally S over n. It's all about counting. It is that simple. Again, it is the context. It is the language that is the challenge. Here's our examples, and it's babies. 3 times babies. You've seen me develop the sample space already. So there we go. All possible arrangements will record gender in the birth of 3 different babies. They range, as you can see, from all boys to all girls and everything in between. So here's a couple of questions for us. The first, what's the probability that 2 out of those 3 babies are girls? And then the second follow-up question, what is the probability that at least 2 out of those babies is a girl? At least 2. So again, it's about the counting. So we want to count the babies that fit the description. For the first question, we're interested in the number of outcomes that have 2 baby girls. Well, you see them there in the yellow color. Girl, girl, boy, girl, boy, girl, boy, girl, girl. So I have 3 distinctly different outcomes that have 2 girls and 1 boy. How many outcomes altogether? A simple count gives you 8. So the probability of 2 girls and 3 boys is literally 3 out of 8. 3 different ways that can happen out of 8 possibilities. 3 out of 8, 0.375. No rounding is needed. We have 3 significant digits as it stands. Now, the follow-up question, what was the probability of at least 2 girls? That means 2 girls or more. At least 2 girl babies? Well, 2 girls plus the outcome where we have 3 baby girls, at least 2 or more, in this case 2 or 3. So the probability that X, being the number of girls, we'll talk more about that in another lecture, at least greater than or equal 2 girls, 4 out of 8 or 0.5. And you'll note in both cases, the outcomes, the 3 outcomes in the first example, the 4 outcomes in the second example, those are all simple events. None of those events can be broken down further. So there we have a couple of very basic examples. You'll notice I didn't even bother putting that up on Mr. Calculator. 4 out of 8, 0.5. So we have reviewed some methods to calculate probabilities along with their very basic definitions. And you've got a couple of examples to look at. This is a challenge. This material, what does help? Practice. Practice does help. All right, we'll talk to you guys later. I'm going to end this now, and I'm going to stop sharing before I overshare. Good luck with this, and I want you to reach out with me for any questions you might have. And I'm going to poke at you about this stuff because it is so important.